Hey guys, I want to start off the video kind of giving you guys a little pep talk. I know it's hard for you to kind of get some of these concepts through the videos only. It's just not the same with me not being there. I promise that we'll get everyone caught up next week, and we will test next week on Friday instead of Tuesday as we originally were scheduled to. So please try not to stress too much. Do the best you can with the lessons that I'm giving you through the videos, and then hopefully we'll clear up any misunderstandings next week. Alright, so today we're going to be looking at what are called secant angles. And so a secant was one of your vocabulary words from Monday, and the two most confused words in the vocabulary secrets of circles are secants and chords. And the reason for that is because all chords are secants, but not all secants are chords. So I know you've probably heard before, I don't know why we use this example all the time, but all poodles are dogs, but not all dogs are poodles. It's the same kind of relationship here. To be a chord, you have to have a segment, and the end points of that segment have to be on the circle. So you see this line going through the circle here. If that segment started at this point and ended at this point, then it would be a chord. But it's extending past those 2 points, so it's no longer a chord. It contains a chord, this part of it is a chord, but the whole segment itself is not a chord. To be a secant, it just has to contain 2 points on the circle. So this segment is a secant because it contains 2 points on the circle. So again, all chords are secants because they contain 2 points on the circle, but not all secants are chords because not all secants begin and end on the circle. They can extend past the circle. So we're going to look at today when we have two secants intersecting, then the angles they form, here's that real original naming of the angle, it's called a secant angle. So that makes sense. If two secants intersect, they're called that they're forming a secant angle. Now there are three cases of secant angles. One of the cases we've already looked at. So here are two secants intersecting at point A. Remember that I hope that it's been stressed over and over again. Anytime you're looking at the relationship between the arcs and the angles, you're only concerned with where the vertex is of that angle. And so the very first angle you learned was a central angle, and the vertex of the angle was the center of the circle, hence the name central angle. We learned that the angle and its arc have the same degree measure. So if the arc was 30 degrees, the angle was 30 degrees. Then we learned what were called inscribed angles, and that's when the vertex is on the circle. And that's exactly what this is. This is an inscribed angle. So remember, when the vertex is on the circle, the angle is half of its intercepted arc. So if this arc was 100 degrees, angle A here would be 50 degrees because it's half. So this is not a new case for us. Our new cases are going to be the second and the third one here. Here is where two secants are intersecting at point H. Now these are not central angles because H is not the center of the circle. And so remember me telling you, you'll be able to tell if it's a center, if it has a defined point. Well, I just put that red point there, but before I did that, those two lines were intersecting and you didn't see a distinct defined point there. So H is not the center of the circle. So this vertex is inside the circle, but not at the center. These are just secant angles. They don't have a special name like inscribed or central, but we're going to be looking at the relationship between the angle and the arcs in just a moment. And then the third case is when the two secants intersect outside the circle. So point Q is outside the circle, and so there's a special relationship between that angle and the arcs. Now, when you look at the ones inside and outside, the arcs that they're intercepting might be a little confusing. It's easy with an inscribed to follow the sides to point C and point B and know you're talking about this arc CB. But if I'm talking about angle DHG, well, there's actually two arcs that are part of that angle, because if we follow this secant right here, it goes to points E and point G. and this secant goes through point F and point D. So this angle actually intercepts two arcs, the one from D to G here and the one from E to F here. Those are the two arcs it's intercepting. So if I was looking here at angle JQL, that angle right there, if you follow its sides, it goes through point P and point J. This side goes through point K and point L. So it also intercepts two arcs, arcs JL and arcs PQ. So the inside and outside angles are going to intercept two arcs each. And you'll see in the relationship that it requires two arcs to find the angle measure. So remember, case 1 we've already looked at. That's inscribed angles. Angle is half the arc. So we're going to look at the relationship of case 2, where the two secants intersect at a point inside the circle. So this point is inside the circle. You can see here S is the center. So these are not central angles because they're not meeting at point S. So here's the relationship. The angle, the secant angle, its degree measure is going to be 1/2 the sum of the two arcs that it is intercepting. So if we're finding the measure of angle 1, this is a side making angle 1 and this is a side making angle 1. The two arcs we're talking about are MA and HT. We would have to add those together and take half of that sum to find the measure of angle 1. So let's look at an example of that relationship. Here we have two secants. They're actually chords, but remember chords are secants, intersecting at point S, and point S is inside the circle. So the relationship, the angle is going to be half the sum of the two arcs. So we want to find the measure of angle WSK, that one right there. So the two secants making that angle are forming this arc and this arc, which we're given the degree measure for both. So I can find the measure of angle WSK by taking half of the sum of those two arcs, 12 plus 42. So 12 plus 42 is 54, and half of 54 is 27 degrees. That's the measure of the angle. Now, if this angle is 27 degrees, then this one would also be 27 degrees, because remember, those are vertical angles. They have to be congruent. We could find these other two angles because together they make a line together. So, for instance, I can find angle WSP's measure, this one right here, because together with the 27 degree angle, they make a straight angle, so they have to add to be 180. So if we took 27 from 180, we would see that these two angles that are vertical angles have to be 153 degrees. So we actually can find all four of those angles simply by using those two arcs to find these first, and then using your linear pairs to find the other two. Case 3 is when the vertex is outside the circle. So here's two secants. CB would be a chord, but CA is a secant. It's extending past, and the vertex is outside the circle. So the relationship here is very similar, except it is 1/2 the difference this time. So remember, mathematically, difference means we're going to subtract the two arcs. It's a little easier to see the two arcs we're talking about here, because if we follow this side to point B and point C, and this side to point D and point E, we see these are the two arcs that are contained within that angle. So obviously this one is going to be a bigger degree measure than this one. So when you do your subtraction, you're always going to do bigger, minor, smaller one when you're finding your angle. So for example, here we want to find the measure of angle C. Remember, it's always about where is your vertex. The vertex of angle C is outside the circle. So the measure of angle C has to be half the difference, which means to subtract the two arcs. So here the measure of angle C is 1/2 of, we follow the sides here, we see that the two angles we're looking at are 68 degrees and 22 degrees. So I'm going to put the bigger one first, 68 minus 22. 68 minus 22 is 46, and so we're taking half of 46, which is 23 degrees. Okay, so that was dealing with secants. Now we're going to talk about tangents, which is another word from your vocabulary on Monday. You may have thought, whoa, are we talking about trig again? This is a different tangent than the tangent that we talk about with trig. Here, a tangent is a line, and it's a line that only intersects the circle at one point. So by that relationship, a tangent has to be outside the circle. There's no way you can have a line inside and only touch it in one point. Even if you had a segment like this, that's not a tangent, because if you extend that segment, it would go through the circle in 2 points. So tangents by definition have to be outside because they can only contain 1 point of the circle. So this is a relationship that we learned on Monday. This is the tangent radius theorem that you learned on Monday, that says if you draw a radius to the point of tangency, it's always going to be perpendicular to that tangent line. So you always have a 90-degree relationship there. So you were able to solve a lot of problems using right triangles as a result of a radius drawn to a point of tangency. All right, so when we have a secant and a tangent that intersect, we have a really creative name for that. We call it the secant tangent angle. Again, not very creative. There are two cases that occur with secant tangent angles. Since tangents have to be outside, there's no way for the vertex of a secant tangent angle to be inside the circle. That's impossible. But they can be outside the circle or on the circle. Now, these are not new relationships because we've already learned about the relationship when we have a vertex outside the circle. It was the same with the secant angle. So again, it really doesn't matter what the names of the angles are. All that matters is where is your vertex. Every single time the vertex is outside the circle, it's always going to be, to find the angle, you're going to take half the difference of the two arcs. So angle Q, the two arcs we're talking about, it only goes to 1 point there, P, and here it goes to 2 points, S and R. The two arcs we're talking about are R to P is the large one, and P to S is the small one. With the other one, where the vertex is on the circle, we've already learned that relationship. Anytime the vertex is on the circle, it's just half the arc. The angle is just half the arc's measure. You don't have to add, and there's nothing to subtract because there's only one arc. So if we're finding the measure of angle B, we follow this side. The only point on the circle was B. C is outside the circle. We follow it here. The only point on the circle was A. So the arc is between A and B in that case. That's what we're finding half of to find that angle. So again, notice the vertex of a secant tangent angle cannot lie inside the circle because tangents can't go inside the circle. So we already talked about the relationships here, but this is in your notes. If you have a secant tangent angle whose vertex is outside the circle, then the degree measure is going to be 1/2 of the difference of the two arcs. So 1/2 of RP minus PS. If the secant tangent has its vertex on the circle, then it is simply half the degree measure of the arc. So the measure of angle ABC is half of arc AB's degree measure. Alright, so let's look at some secant tangent angles here. So we are told that CR is tangent. We don't have to assume that. So remember, if CR is tangent, the point on the circle is called a point of tangency. So point T is a point of tangency. We are asked, we're told it's circle T, so that's the center. That's not real helpful here. And we want to know the measure of arc CDN. So we're wanting to know this arc right here. That's our unknown. So I'm going to put X, but just know it goes from C all the way to N. Oh, sorry, we're not finding it. We're told it. So I don't know why I put X there. Ignore that. Let's write that as 200 as it was given. Alright, we're trying to find the measure of angle R. Maybe it's my fever that's reading things wrong. So this is our unknown right here, the measure of angle R. Now where is the vertex of that angle? Angle R's vertex is R, and it is outside the circle. So remember, anytime the vertex is outside the circle, the relationship is it's 1/2 the difference of the two arcs. So measure of angle R will be 1/2 the difference, which means to subtract. Now what two arcs are we talking about? We follow this one only to point C. We follow this one to M and N. The large arc is N to C. The small arc is from C to M. Okay, so we can find the measure of angle R by finding 1/2 of the larger arc, which is 200, minus the smaller arc, which is 50. 200 minus 50 is 150, and half of 150 is 75. So the measure of angle R is 75 degrees. Now, let's say I was not given the measure of arc CDN. Let's take that 200 degrees away. And let's say instead I was given N to M is 110 degrees. Well, 110, this arc 50, and the one we don't make, or don't know, make up the whole circle. So we could have found the arc we needed by adding these two together to get 160. Subtract that from 360, and we would have found that arc to be 200, which we needed for the problem. So it won't always give you this angle. It might give you this arc, I should say. It may give you this arc, and you will have to figure out the arc you need using the fact that they all have to make the full circle, which is 360 degrees. All right, let's look at the next example. Here we have a tangent, BA, so that's a point of tangent C, and we have a secant, BC, because it contains 2 points on the circle. Their vertex of that angle formed is point B, which is on the circle. So to find the measure of angle ABC, since the vertex is on the circle, it's simply half of the arc. We don't add or subtract because there's only one arc. If you follow side B, the only point on the circle is B. If you follow this side, we have B and C here. This is the only arc we're talking about, is between B and C. So the measure of angle ABC has to be half of that 100 degree arc. So the measure of angle ABC has to be 50 degrees. Again, if I wasn't given the 100 and instead I was given this arc, this major arc, CKB, to be 260, I could find that arc by just simply taking the 260 from 360 and getting that 100 degrees that I need for the problem. So they might not always give you the ones that you need, but you can figure them out. Alright, so we've looked at secant angles, we've looked at secant tangent angles, and the last type of angle we need to talk about is a tangent-tangent angle. So you can probably figure out from the name, it's when two tangents intersect. Well, since tangents have to be outside the circle, they're only going to be able to intersect outside the circle. So there's only one case of the tangent-tangent angle, and that is when the vertex is outside the circle. So again, this is not a new relationship. Anytime the vertex is outside the circle, it's 1/2 the difference of the two arcs. Now I want you to see what's special about the two arcs here. When we follow this side of the angle, it only goes to E. When we follow this side, it only goes to S. So the two arcs made with point E and S are the major arc between E and S and the minor arc between E and S. So together, they make the full circle. So you only need to know one of them, and you'll know both of them. So for instance, if I gave you the measure of arc E to S is 100, then you know this one has to be 260, so that they add to be 360 together. So to find the measure of angle T, we would take half of 260 minus 100, half the difference. So let's look at example here. We have two tangents intersecting at a point outside the circle, and so we know that the measure of angle A is 1/2 the difference of the two arcs. Again, the two arcs only involve points K and T. One of them is K to T, the major arcway, and one is K to T, the minor arcway. We're only given the minor arc, but I can find the major arc since they make up the full circle together by taking 360, the full circle, not equals, but minus, the minor arc, which is 110. So it has to be 250 degrees. So to find the measure of angle A, we want 1/2 of the larger one minus the smaller one. 250 minus 110 is 140, and half of 140 is 70 degrees. Okay, I want you to pause the video here and work on the your turn problems. Just be careful. Number 1 asks for 2 answers, the value of x and also the measure of angle r. This one also has 2, but it's separated by problem number. So take a minute and try to work those on your own, and then come back and replay the video to see the answers. Okay, so these are the answers you should have gotten on the year term problems. On number 1, to find the value of x, you had to use angle r, whose vertex is outside the circle. So remember, when the vertex is outside, the measure of the angle is half the difference of the two arcs. Well, the measure of angle r is given as an expression. So this side of the angle is known as x minus 12. It's going to be 1/2 of the difference of the two arcs it makes, which here's the big arc here, x plus 38, and we're going to subtract the small arc, which is the 30. Now, in order not to have a fraction, to me the easiest thing to do at this point is to multiply both sides of the equation by 2. But don't forget, when you multiply x minus 12 by 2, you have to distribute times both terms in that binomial. When you multiply this side by 2, all that happens is that gets rid of the 1/2. It doesn't affect the subtraction part at all. So here we would have 2x minus 24, and when the 2 and 1/2 cancel here, all I have is x plus 38 minus 30. Well, 38 minus 30 is 8, so I just have x plus 8. Then I have variables on both sides that I can subtract x from both sides, and now have x minus 24 equals 8. Add 24 to both sides and get x equals 32. So the measure of angle r is half the difference of the two arcs. Now that's the value of x, but it also asks me to find the measure of angle r. So to find the measure of angle r, all I have to do is put that 32 in place of x here. So the measure of angle r, since it's x minus 12, would be 32 minus 12, which is 20 degrees. Just to make sure that it's correct, I would put your value of x in for the other arc as well. So 32 plus 38 would mean this arc would be 70. So you can check, is 20 degrees half of the difference between 70 and 30? Well, 70 minus 30 is 40, and half of 40 is 20. And so it checks out in that relationship. On number 2, you're asked to find the measure of arc OT. So here's OT. I put an X there for that unknown. Now, the vertex of the angle making that arc, that angle is 92 degrees. The vertex is R, and that's inside the circle. But it's not the center point, so it's not a central angle. So measure of arc OT is not 92 degrees. It would be if this were the center, but it's not. So remember, when it's inside, it's half the sum. So the measure of that angle is half the sum of the two arcs. Well, we know the measure of the angle. It's 92. And so it is going to equal 1/2 the sum of the two arcs, which are 84 and x. So again, I multiplied both sides by 2. 92 times 2 is 184. When I multiply this side by 2, it just gets rid of the 1/2 and leaves me with x plus 84. So when I subtract 84 from both sides, I got x equals 100, which means the measure of arc OT is the 100 degrees. So again, you can check that. Is 92 1/2 of 84 plus 100? Well, 84 plus 100 is 184. Half of 184 is 92. so it checks in the relationship. And finally, the last one, you're told that AC is a tangent and DE is a tangent. So point D is a point of tangency here for this ray, and C is a point of tangency here. So when we're asked to find the measure of angle A, remember you always want to ask yourself, where's the vertex? Well, the vertex is outside. So you know the measure of angle A is going to be half the difference of its two arcs. And you were given both of those arcs. Here's the big one at 156. Here's the small one, which is 76. 156 minus 76 is 80, and half of 80 is 40. So the measure of angle A is 40 degrees, half of the difference between those two arcs. Then you're asked to find the measure of angle BDE. Where's the vertex, the center letter of that angle? It is on the circle. So anytime your vertex is on the circle, your angle is simply half of the arc. The arc that it's intercepting is this one right here. Now, it did not tell you the degree measure of that arc, but you knew the rest of the circle. So all you have to do to find this degree measure is to add the two arcs you knew, 156 and 76, and subtract that from 360 for the full circle. So that tells you that arc is 128. So the measure of angle BDE is half of that 128, which makes it 64 degrees. Okay, so your homework tonight is going to be worksheet 5, but I just want you to understand again that you only have 4 relationships all together with arcs and angles. It's all about where is your vertex. If your vertex is at the center of the circle, then remember your angle measure is equal to the arc measure. If your vertex is on the circle, the angle is half the arc. If the vertex is inside, the angle is half the sum of the two arcs. And if the vertex is outside, the angle is half the difference of the two arcs. So it really doesn't matter if it's a secant angle, a secant tangent angle, a tangent tangent angle. All that matters is where's the vertex. There are only 4 relationships. All right, hopefully, I will see you Monday.